This is the Securing the Netbackup Environment lesson. This is the 10th lesson in this course. In this lesson, you'll learn about security issues that affect backup environments and NetBackup features that mitigate those issues. You'll learn about how to secure NetBackup port communication, how to encrypt NetBackup data, how to configure NetBackup access control, and how to audit NetBackup. This is the Understanding Security Concerns in a Backup Environment topic. Security is a common concern when dealing with important corporate resources and data. Although some security-related issues are solved with procedures and/or software that are beyond the scope of this course, backup environments have specific security issues that should be discussed and addressed. This slide shows some common concerns, such as the security of backup data, the management access to the backup application, the security of the networks themselves and the ports in use, and the shipping of physical media to support DR requirements. NetBackup offers a number of security-based features to help address the security of your backup environment. Auditing allows you to track which users have been accessing NetBackup functionality. Access control allows you to control access to the NetBackup software and can provide for enhanced authentication and authorization. Encryption is available using one of a number of methods which can provide encrypted media to send off-site, can be used to encrypt backup data from the client in cases where the network is not trusted, or can be used to provide at-rest data encryption in deduplication pools. This slide describes some options for securing NetBackup. First and foremost, it's important to upgrade to the most recent NetBackup version available. Security improvements is a top priority in recent versions of NetBackup, and each recent release has improved the overall security topology of NetBackup. It's also important to secure your environment and network, and to be familiar with how NetBackup communicates, particularly in relation to firewalls. Encryption of data is recommended and can be accomplished using several means, most of which we'll discuss in the course of this lesson. Access control is available for NetBackup. It's not active by default, but you have several choices which provide a trade-off between complexity and thoroughness of protection. The auth.conf file can be used as a simple means to restrict the actions of NetBackup console users. Or, to step things up a little bit, enhanced auditing can be used for limited role-based administration and user-based auditing. Or for maximum protection, NetBackup access control can be used for granular role-based administration. These options will also be explored later in this lesson. The NetBackup auditing feature can be used to track configuration changes and to maintain accountability. This is the Securing NetBackup port communication topic. TCP/IP ports are used by NetBackup for client and server communication. NetBackup essentially does all communication via TCP, both within the host and between hosts. NetBackup uses two classes of ports: reserved ports, 1023 and below, which are privileged and accessible to the operating system only, and non-reserved, which are 1024 and above, which are generally accessible to all user applications. Port assignment can be either registered or random, and there are some NetBackup daemons and services which use well-known ports that have been registered with IANA and therefore are exclusively for the use of NetBackup. Other ports can be assigned dynamically by the operating system as a matter of need. Now, dynamic assignment of ports is never really used these days for communication between hosts because it is so common for firewalls to exist between hosts. And so NetBackup uses processes such as PBX and VNetD to cut down on its port usage between hosts. In most cases, those two ports, the VNetD port and the PBX port, are the only ports that are used between hosts, although there are some NetBackup features that will sometimes require opening additional ports. However, this behavior of dynamic port assignment where Netbackup just grabs a random port from the operating system, is used only for the sending of data between hosts, because the sending port won't really impact a firewall. It's the listening port that impacts the firewall. And for communication within a host, where the exact port in use is less of an issue. Netbackup has been moving away from the use of registered ports, so older Netbackup daemons and services will still have well-known ports assigned to them. However, all of the newer processes and services, anything that's been added to the product after Netbackup version 6, will usually communicate via PBX. This slide describes Netbackup process communication methods. Most communication on Netbackup servers between processes is done using PBX. PBX was added to Netbackup in version 6, and it reduces the port usage by channeling traffic through a single port. The PBX port is 1556. PBX stands for the Private Branch Exchange, and it's an implementation of the CORBA, Common Object Request Broker architecture, which is commonly used for inter-process communication because it provides for managed communication, where there's control over the communication rather than just being an unmonitored socket. It's also very handy for getting applications that were written in different programming languages to be able to easily communicate with each other. So PBX was introduced in version 6. All of the new processes that have been introduced since version 6 all use PBX by default, and with each release of Netbackup since version 6, more processes have been switched over from using the legacy communication methods to using PBX. So as of Netbackup 7.7, PBX is used by most Netbackup processes. Most, but not all. There are still some older processes which use legacy communication. Legacy communication is sockets. It means that there's a port used for sending and receiving between two processes. Now, when this communication is going to take place between hosts, we use VNetD on port 13724 for the communication between hosts. And that's to be firewall friendly. It means that for the vast majority of Netbackup communication between hosts, there's two ports that we'd want open in the firewall, PBX 1556 and VNetD 13724 for bidirectional TCP. This slide shows an example of the ports used for communication between Netbackup master servers, media servers, and clients. You'll notice that most communication is all happening over PBX, port 1556. There are some legacy ports which are still used. You'll notice that when NBAC, Netbackup Access Control, is configured, it requires the use of additional ports. And there are other features in Netbackup which can sometimes require the use of additional ports. For a comprehensive discussion of port utilization in Netbackup, consult the Netbackup Security and Encryption Guide, which has a lot of detail on the subject. This slide is a summary of some of the additional ports used in Netbackup communication. Again, the vast majority of communication is all happening over 1556 PBX or 13724 VNetD. We see that there are ports that are used when NBAC is used, for example 13783 for the authentication server. There are ports that are associated with Netbackup's deduplication. 10082 and 10102 are used by MSDP pools for any kind of deduplication communication, and by that I mean either client-side dedupe, optimized duplication, or error replication through a firewall would use those ports. You'll also notice that there are some ports mentioned on the slide here which are not really Netbackup ports, but they're operations that Netbackup might be initiating. So for example, if you want to get emails when your catalog backups are successful, you need to make sure that the sending host has the SMTP port open. If you want to use SNMP traps with Op Center, we need to make sure that the standard SNMP ports are open. Netbackup appliances sometimes have port requirements for remote lights-out management. So again, the relevant documentation, the Security and Encryption Guide for Netbackup, and the security guide for Netbackup appliances has additional detail. That much being said, this slide is a pretty good, pretty comprehensive list of the ports that would be used in Netbackup. This is the encrypting Netbackup data topic. Encryption is a commonly requested security feature to prevent the interception of data by unauthorized parties. Now, before you really get started with incorporating encryption into your backup operations, there are some questions and some planning that you should be thinking about. Namely, what are my needs for where data needs to be encrypted? Does it need to be encrypted at rest or in flight at both? What is the driver for encrypting the data? Does it need to be encrypted in a complete data path or only for parts of it? And what are my deployment cases for encryption security? Netbackup supports a number of different methods of encryption, some of which are provided by the Netbackup software itself, and some of which come from outside of Netbackup but still integrate with it. Each encryption option comes with some advantages and disadvantages. Some options have a lot more advantages than disadvantages, and for some the reverse is true. We're going to be exploring different encryption options in a fair amount of detail in this topic, but this slide is an excellent kind of a quick reference card for comparing the pros and cons on a single sheet of paper. First up is MSDP encryption, which can be used with Veritas MSDP dedupe pools. This encryption takes place entirely within the dedupe engine. So it's nice because it doesn't require a lot of management by the administrator. You don't need to generate or manage keys. The keys are generated automatically within the dedupe engine, and they're automatically tracked and moved as necessary by the dedupe engine, for example, when you're doing replication. Encryption is not enabled in MSDP pools by default because there is a performance overhead associated with it. However, it's a much smaller performance overhead than you would see with other forms of encryption. And that's because when you do MSDP encryption, the data is deduplicated first, and then the encryption is applied. You have to do it that way, or else you'd get 0% dedupe rates. And the real benefit here is only the changes are being encrypted. Anytime you do write data to a dedupe pool, you're only ever writing changed data. So that's less stuff that needs to be encrypted and less additional overhead. But because, many customers are very sensitive to performance, we don't activate this by default. What we would do is we would edit the settings in the pd.conf file to enable encryption. You'll notice from the examples on the slide here, compression is enabled by default. Encryption is not. Veritas testing has showed that compression essentially adds 0 performance overhead to MSDP operations, so we might as well have that turned on by default and save the space. Encryption encounters a slight overhead, and so we leave that off by default. Now you can choose to have encryption turned on at the dedupe pool level so that data sent from the media server to the pool is encrypted. Then the data will also remain encrypted at rest. Also, if the data is moved to another pool via optimized duplication or air replication, it will be encrypted in flight and therefore encrypted at rest in the target dedupe pool. Now, optionally, if you had clients doing client-side dedupe, you could also have encryption between the client and the MSDP storage server. And that's nice because it means that the data is encrypted across the entire path that it travels. Now, data that's transferred to an MSDP pool is always sent via SSL, and that's whether or not encryption is turned on. And this dedupe uses the Blowfish 128-bit algorithm for encryption. The actual encryption key is 256 bits because it's a concatenation of a Blowfish-generated 128-bit key plus a 128-bit key derived from the fingerprint used to deduplicate the file. But because Blowfish is only generating 128 bits of it, you can really only claim 128-bit encryption. That's one limitation to MSDP encryption, is that some strict security standards may not allow for 128-bit encryption. From a real-world perspective, the way MSDP pools operate, each individual segment of data has its own encryption key because it has its own unique fingerprint. So even if I managed to get an exploit or I got access to an encryption key, I wouldn't be able to reveal more than one segment of data, 128 kilobytes by default. It would take a massive effort to decrypt the entire pool. So it is a very secure solution, but maybe it's not one that will hit all the checkboxes on everybody's SLA. This slide discusses Netbackup client encryption, which is sometimes referred to as Netbackup policy-based encryption because the option for this is an actual checkbox on the Netbackup policy attributes tab. This is one of the oldest versions of encryption that Netbackup supports, and it involves generating keys on individual Netbackup clients and then using those keys to encrypt the data before it's sent to the media server. Now, there's a number of pros and cons that are associated with this. I'll talk about the pros first. The advantages are that there's different keys for each client, and that those keys are under the control of whoever is administering that client. And for very security-conscious folks, particularly managed service providers, that might be a big advantage. Theoretically, you could have a situation where the backup administrators don't actually know what the encryption keys are for these individual clients. Of course, the downside here, and you might already be thinking about this, is every client's got its own set of keys that has to be generated, maintained, and protected. Remember, those keys must be available at the DR site in order to decrypt the data, or else my DR efforts will be entirely futile. So there is more coordination that's involved here, and of course more work, because I have to visit every client to enable this encryption. Switching back to another benefit, though, it does mean that the data is encrypted across its entire data path, from the moment it leaves a client all the way through to the target storage unit. This encryption is performed entirely by the client, which sort of leads us to another disadvantage of using this method, which is it's a high overhead form of encryption. It's all done in software on the client, and if you want to have any compression for your backup, you'll need to be using the policy-based compression checkbox as well, because once the data is encrypted, it can't be compressed. So you're talking about having a client compress the data and encrypt the data before sending it to the media server, and that's a significant amount of additional work. Testing that Veritas has done has seen impact of up to 40% increase in backup time when using these features. So for performance-minded encryption, this may not be the first feature to reach for, but if you're looking for some of the other advantages, such as encryption across a complete data path and independent management of encryption keys, this feature might be attractive. Now, the key file needs to exist, and that's generated on the client by using the bpkeyutil command. And then the encryption attribute gets checked off on the backup policy. And then for each file, the client creates an encryption tar header with a checksum of the key and a Netbackup cipher that's used. And you get to select which cipher is used, with the default being AES 128. The Netbackup catalog will track whether a particular backup was encrypted or not. When setting up client encryption, for each encrypted client, use the bpkeyutil command, and Netbackup will use a passphrase that you specify to create the key file. Now, the bpkeyutil command can be used to set up several clients simultaneously, which will save some time there. Be careful when doing so. Make sure that current and previous passphrases are secure and retrievable. It's an excellent idea to have these written out on a good old-fashioned piece of paper and stored on a safe in the disaster recovery site to guarantee that they'll be available for DR operations. Because if a key file is damaged or lost, all previous passphrases are needed to recreate the key file. Without the key file, no restore is possible. Once the key files are configured on the clients, then encryption can be enabled on the policies that are protecting those clients. That's just a matter of hitting the encrypt checkbox on the backup policy. Note that this example, the compress box is unchecked, it would be common to check off both options. Because remember, once data has been encrypted, no form of compression is going to be effective. It's not going to be very effective anyway. So it's desirable to compress the data first and then encrypt it, which can be done by hitting both checkboxes here. The client's host properties can be used to adjust encryption settings. The default setting for the encryption permissions is allowed, which means that encryption is allowed but not necessarily mandatory. I could change that to required if I wanted to mandate the use of encryption anytime that client was backed up. Or I could do the opposite, set it to not allowed, which would mean that encryption is not permitted on that client. And I can also use the settings down towards the bottom to adjust the strength and the cipher being used. We mentioned the default was AES 128, although there are 256-bit options available as well. Another aid to encryption is Netbackup's key management service. The key management service runs on the master server and can be used to manage encryption keys for other services. And the other services I'm really talking about here are tape drives that support the L10 encryption standard. That's usually found in LTO 4 or later generation tape drives. Also, some cloud service providers can work with Netbackup's KMS. So KMS is not providing encryption itself. It is a centralized way to manage your encryption keys. And that can be very desirable to keep everything under Netbackup's control, and then you know that it's protected in case of disaster recovery. This is a function that's included with Netbackup and doesn't require any extra licenses or anything like that. Of course, it requires hardware or a service that supports encryption. Now, there is a lot of advantages if you're looking for encrypted tapes to using the native encryption that's available in L10 compliant drives because it eliminates the performance overhead that's often associated with encryption. It's all done natively by the tape hardware. And so this is an option which is very popular. Here are some considerations when using KMS. As we mentioned before, this functionality is provided by the master server, by the NB KMS service, and encryption keys are provided to the tape manager process on the media server when needed. So the management of this is all done from the master server as the root or the administrator on an appliance, which is what we want. We want centralized control of these keys. The slide lists the different supported ciphers, with AES 256 being the default. And what we're doing here when we do backups to tape using KMS is we're going to use volume pools with the name prefix ENCR_, and that's the flag for us as administrators that says, hey, any backups that go to this volume pool are going to get encrypted. You can have KMS auto-generate encryption keys, or the recommended method is to generate encryption keys from passphrases. And that's nice, again, because then you can record these passphrases in a secure location in case for some reason they're ever lost. This is the Configuring Netbackup with Access Control topic. This slide describes different methods for configuring access control in Netbackup. The default behavior from Netbackup, what the product was originally written with, was the idea that only the administrator, i.e. the root user in Unix or the member of the administrators group in Windows, was really going to manage the product. There is a growing need among security-conscious customers to have non-root users do Netbackup management, but to be able to enforce access control and to enforce auditing for tracking what folks are doing. And so you can see the three major options over here. One is to use the auth.conf file, which is a file that allows you to configure which users have full access to the Java Netbackup Administration Console. And the Java version of console is now the only version of the console supported on Netbackup 7.7 and later. So users in auth.conf have full console access. It does not affect CLI access. You still need to be root or administrator in order to run most Netbackup binaries. A limitation to using this method is that all auditing is done as an admin, In other words, when you look at NetBackup audit trails, you're only going to see actions were performed by either root or administrator. You're not going to get any more detail than that, no matter how the user is logged in. And so an improvement that's been added recently to NetBackup is enhanced auditing, and that allows for auditing with the real user name, so that you see the actual user who's logged in and not just root or administrator. Now, the most robust security controls we can add is a NBAC, NetBackup Access Control, and that provides for very granular control, not only of who can access NetBackup, but with really tight authorization of what they're allowed to do. This particular user can do this and this, but not that. You can get much more granular with NBAC than you can with either of the other two solutions, and you also get the ability to audit using the real username. The downside is NBAC is more complex to configure than the other two options. We'll explore the configuration of these options in this topic. We'll discuss the auth.conf file first. Now, this is a file that has been present in NetBackup for a long time. As far as I know, as long as there's been a Java NetBackup console, this file has existed. Now, by default, NetBackup only allows the root or the administrator user access to the console. But by editing auth.conf, we can add additional users, and those additional users can be given full control of the console, or to some extent their access can be limited. Your ability to limit things with auth.conf is very broad categories. They're detailed in the NetBackup administration guide, exactly what permissions you get with each level of authorization, but they're not terribly granular. There are some platform-specific differences to auth.conf. In Unix, this file exists by default, and it provides NetBackup administrator permission for the root user. For all other users, they're restricted to just user backups and restores. Essentially, if you try to open the console as a non-root user by default, you're really just going to get the bar console. Now, those permissions for other users can be adjusted by using this file. Windows does not have this file by default, but it does come with a template authorization file that can be used to create an auth.conf file. This template is located in the NetBackup Java directory, and it contains a sample entry to get you used to the syntax for the auth.conf file. And again, full detail about exactly how to configure this is in the administration guide. Here's an example of configuring a non-root user using the auth.conf file. In this example, I've added a user named Nova, and that user has permission to access the activity monitor only. And so auth.conf will regulate whether or not you can access the console, and if so, what parts you can access, again, fairly broadly. Note that the auth.conf file only applies to the NetBackup console. It has no effect on the NetBackup binaries. And so the rule of thumb here is still, if you're root, you can access all of the NetBackup binaries. If you're not root, then many NetBackup binaries cannot be run. For some time, customers have been looking for a way to improve access control to something more robust than is available just by using the auth.conf file, but without necessarily installing full-blown NBAC on their systems. So NetBackup 7.7 introduces a feature known as enhanced auditing, and this is an enhanced auditing that's simple to administer, but it provides for more access control. This user management is performed by NetBackup administrators, and the access control is binary, by which I mean you're either giving no access or full administrator access. The management for enhanced auditing is performed with the bpnbaz command. And so you can see example syntax on the slide here of creating users, deleting users, and viewing their privileges. By default, NetBackup does not mandate user authentication. However, when NetBackup is configured for enhanced auditing, user authentication from the master server is mandatory, and the behavior is slightly different on different platforms. On Windows, this authentication should take place automatically through single sign-on. If the single sign-on is not successful, then the user must run the bpnbat command -login in order to authenticate with the master server. On Unix, if you're a non-root user, you must always run the bpnbat command -login in order to access Netbackup. Both auth.conf and enhanced auditing can be used simultaneously. Note that entries in auth.conf supersede access control for the Netbackup administration console, whereas the enhanced auditing is primarily focused on access to Netbackup binaries. Remember when reviewing this information that the root user always has complete access to the Netbackup console and the Netbackup binaries. Again, we're really focused on non-root users here. And so if a non-root user has an auth.conf entry, they'll be granted access to the Netbackup administration console, at least as much access as is specified in the auth.conf file. It might be complete or it might be restricted. As far as access to Netbackup binaries go, by default, non-root users have no access to them. However, they can be granted access by using enhanced auditing. And that's a binary kind of a thing. It's an all or nothing when you use enhanced auditing. This table on the slide does a pretty good job summarizing the different permutations here that a non-root user would have, depending on if they have an entry in auth.conf or not, and if enhanced auditing is active or not. Netbackup Access Control is the most robust and configurable role-based access control feature available in Netbackup. It allows you to create users and groups and to be very specific in the permissions that they're assigned. NBAC consists of two complementary services, Netbackup Authentication and Netbackup Authorization. Netbackup Authentication is all about proving that you are a legitimate user, whereas authorization is all about restricting how much ability authorized users have to manage the product. When you use NBAC, users will authenticate against an existing security directory, such as NIS or Active Directory. And so the NBAT component is really just authorizing users against an existing security domain. You're not creating an entirely new domain here for NBAC. NBAC does not require any additional licenses, but it does introduce a level of complexity to the Netbackup environment. It's more complex than the methods we've discussed previously in this topic, and it can add complexity to some procedures, such as upgrade procedures, and there are some circumstances where it's not supported. Netbackup appliance master servers don't support NBAC, media server appliances do, and some Netbackup agents don't support NBAC, as noted on the slide here. This slide shows some examples of customizing Netbackup permissions with NBAC in the Netbackup administration console. Now, I have done some setup steps prior to this where I have established a trust relationship between the Netbackup authorization broker, which is usually located on the master server, and whatever security domain I am authenticating against, such as Active Directory. And then once the authentication piece is in place, then I can move on to the authorization, which is what I'm really looking at here. I've got the ability to create users within Netbackup and to organize them into groups, and then to decide what level of permission I'm going to delegate to groups. And as you can see on the slide here, it's pretty granular. They have an example here of a Netbackup operator, which is a default group that's created when you enable NBAC, and by default it comes with a set of permissions that we think by default would be appropriate for someone whose role is an operator. And of course you can go in there and adjust them and either give them more or less permissions depending on your individual needs. This is the Auditing Netbackup topic. Netbackup 7.7 supports audit reports on policies, job management, storage units, storage servers, disk pools, and volume pools. This auditing is enabled by default in all new Netbackup installations. Upgraders may need to enable auditing manually. By default, only the root or administrator user can perform Netbackup operations via the command line or via the administration console, However, we have explored in the previous topic how I can use enhanced auditing to broaden those permissions so that non-root users can access NetBackup binaries, and how I can use the auth.conf file to grant non-root users access to the NetBackup administration console. Auditing has been in NetBackup for several versions now, and it's good on keeping track of who's making changes to things. The limitation that has existed for a long time is that everyone's making changes as root in Unix or administrator in Windows, and so the audit trails always show all actions being performed by root, which is not always very helpful if you're trying to enforce individual accountability. Now, in the past, the only way to change that was to use NBAC. If you enabled NBAC, then in the audit trails, folks would show up as the actual user they were logged in as. But not everyone wanted to use NBAC because it comes with, as we've seen, some complexity and some limitations. So in 7.7, one of the benefits of using enhanced auditing is that in addition to the access control, it allows users to show up in the audit trails as the actual user they're logged in as, instead of showing up as just root or administrator. And so I can use enhanced auditing along with the auth.conf file to handle access control and to get better accuracy in my audit trails. Or if I needed very robust security, I could go with NBAC. Note that enhanced auditing and NBAC are mutually exclusive. I'm either going to choose one or the other. Here are some examples of verifying and configuring NetBackup auditing. I can use the nbemm command, as shown in the example, to prove that audit trails are enabled. Again, in new installations, they'll be enabled by default, but if I'm upgrading, I might need to go through and manually enable it. I can use the nbemm command to enable or disable auditing. Although auditing is enabled by default, enhanced auditing is not. As there's an extra step here to configure that, we use the bp-nbaz command to enable enhanced auditing. We run that command on the master server, and then we restart the services. Typically, this is a one-time action. I just turn enhanced auditing on and probably leave it on forever. If I ever wanted to disable enhanced auditing, I could do that using the bp-setconfig command to add use authentication equals off to either the bp.conf file on Unix or the registry on Windows. Some NetBackup commands support the use of the -reason option, and that can be used to indicate why a particular action was performed. And if this switch is used, the -reason will be captured in the audit trails. Only commands that support auditing will support this, such as commands for policies or storage units. Audit trails can be viewed either from the command line or from the Ops Center interface. This is an example here of using the nb audit report command from the CLI in order to view audit information. This slide shows some sample output using the nb audit report command. The first command shows summary information, which is the default view. The output shows two entries, one in which a policy was created and one in which it was modified. Note that they use the -ctgy policy option, which means that only policy-related changes show up and only items between the start and end date that are specified. Now, the second example here, a couple things are different. Instead of specifying a range of dates, a start and an end, we specified just a start date. Again, the category is policy, but we use the -fmt detail switch as well, which means we're going to get detailed output. And so, as a result, we see that there is more output here because we had a longer time range that we were auditing, and that there's much more detail. We can see the exact changes that were made when a policy was modified, and we can see the reason, which in this example looks like it would map back to a ticket that someone put in. Audit trails can also be viewed in the NetBackup Ops Center console under Monitor Audit Trails. There are controls here to be able to filter the output to particular categories and to filter by time range. These records are downloaded from the master server to OpCenter periodically and stored in the OpCenter database. They're retained in OpCenter for a period of time, which is configured within OpCenter. And so that means that retaining audit records on the master server itself is only necessary if you want to be able to view audit records using the command line on the master server. This slide shows some optional auditing configurations. If you wish to connect to a media server when you're using enhanced auditing through the Netbackup Administration console, you'll need to first generate a security certificate for that media server, which is a one-time task. Also, with the Netbackup console, if you want to change servers when you're using enhanced auditing, you'll need to set up a trust relationship between your current master server and the master server that you wish to change to, and that again would be a one-time only action. If you wish to audit host property changes, NBAC is required. In this lesson, you learned about security issues that affect backup environments and Netbackup features that can address these issues. You learned about Netbackup communication, how to secure data at rest and in transit using encryption, and how to improve access control using auth.conf and enhanced auditing. This concludes Lesson 10.